Do you have your Chapter 10 note card ready? I hope so, because your test is coming up. Here is our Chapter 10 test review. And on some of these, I am going to write down what theorem we used so that you know basically where it came from. Okay, so let's get started. Number 1, if you want to find AB, this is one of those that, remember, we kind of redrew it outside of our circle. So if I redraw this, I'll go all the way to AD, and I know that B is somewhere between, and between B and D, halfway is C. I know that CD is 3, and because that is a radius, and so is CB, I know that CB is also 3. And over here, I know that the radius of circle A is 10 units. Well, AD is also a radius, so AD is also 10. I want to find the length of AB. So what I have already is this length right here. This is 6 units. And if the whole thing is 10, how can I find AB? It's just 10 minus 6, which is 4. So AB equals 4. All right, let's look at number 2. We know that we want to cut a hole in this table. So here's my circular table. Here's my hole I'm going to cut. And I know that the hole is 20 inches in diameter. And I want to put a metal frame around it. So if you're thinking around it, I'm thinking of circumference. So I need to know my formula, which is pi equals pi diameter. If you don't know that formula, I highly recommend making sure that it is on your note card. Let's substitute in what I know. The diameter is 20, so 20 pi. Now, I want to know the length of it. I don't know about you, but I don't know how long 20 pi is. So since we're dealing with inches, put it in your calculator. And let's say, round to the nearest tenth, 62.8 inches. All right, number 3. This one's a little complicated. We know that this angle is a right angle. Therefore, this angle is a right angle. PQ is 37 degrees. Now, if you look directly across vertically, MQ is also a vertical angle, so MQ is also 37 degrees. I want to find the measure of QLN. Well, I want to find X, but I know that equation. I know that MLN is 90 degrees. I can find arc QN by subtracting MQ, which is 37 from 90. And I get 53. If arc QN is 53, angle QLN is also 53. But I also know that it also equals 2x minus 5. Let's go ahead and solve for x. And I divide by 2. X is going to be 29. And that is what I wanted to know. Number 4. Now this does not have a picture, and I don't know about you, but I'm a visual person. I need to picture what all of this is. I know my circle is C. I know it has a radius of 16 units, and I want to find the length of the arc that has a measure of 270. So 270 is from here, A, all the way around to here. So I'm going to put another point on my circle so that I want to know the measure of arc A, B, D. Just giving it some number or letters. Now remember, it says the measure, so we're talking about a piece of the circumference. And that formula was this: x over 2 pi r equals x degrees over 360. And I think in our book we used the letter L. So let's use the letter L. We don't know the L. Excuse me. We know our radius, so radius is 16. So 2 pi times 16. The x degrees, it's right here, 270. Okay, let's go ahead and cross multiply. We get 8,640 pi equals 360 L. We want to know what L is, so divide both sides by 360. And our length is about, it says round to the nearest hundredth. It's about 75.40 units. All right, let's look at number 5. Turn the page. Okay, number 5. This is theorem 10.4. So if you don't know what that is, look it up in your book. It basically says if DE bisects, which means cuts it in half, and this happens to be a radius, the measure of angle BCE, what it says is that it makes these two lines perpendicular, the chord and the radius. So if they're perpendicular, it forms right angles. So BCE is 90 degrees because of theorem 10.4. Okay, number 6. We want to find the radius of circle O if xy is 10. So if xy is 10, this kind of follows the same theorem. That means this little segment is 5 and that little segment is 5. Here's the radius. Remember we drew a triangle? And I don't know how long this is, and I don't know how long my radius is. So let's say this little piece right here, this piece of the radius is x. That means the radius is x plus this little amount 2, x plus 2. If I redraw this over here for you to see, here's my right angle. This bottom part is 5. This top part is my x, and here is my radius, OX. This is x plus 2. I can solve for x by doing the Pythagorean theorem. Remember we did this in class a lot. So 5 squared plus x squared equals x plus 2 squared. Please, please, please remember to FOIL this x plus 2. A lot of us were forgetting to do that. So 25 plus x squared equals x squared plus 4x plus 4. Let's combine our like terms, minus x squared. Hey, those cancel out, that's nice. So let's move our 4 to the other side. And I get 21 equals 4x. If I divide by 4, I get x equals 21 over 4, which is 5.25, which is great. But I want to know the radius. And remember, the radius is this length from O to x. My radius, I said, was equal to x plus 2. So if x is 5.25, if I add 2 to that, my radius is going to be 7.25 units long. Number 7. This one follows theorem 10.5. point 6, which was about inscribed angles. And it said if you have an angle on the circle, not on the center, but on it, it's inscribed, then the arc opposite it is equal to twice the amount. So x is equal to twice the measure of this angle. So x is 96 degrees. Make sure you know that theorem. Alright, number 9. Nonagon, how many sides? 9. I want to know the measure of arc AC. Well, here's arc AC. Arc AC is actually made up of arc AB plus arc BC, right? It's the arc of both of those. If I have a nonagon, a 9-sided figure, that means my circle is split up into 9 parts. So how big is each little arc? I can figure that out by dividing 360 by 9, and I get 40. That means each arc is 40 degrees. So arc AB, 40. Arc BC is also 40. So arc AC has to be 80. Okay, number 9, another one. You could graph this if you wanted to. I am going to just draw it here. Here's my circle, P. And I have a line that's tangent, line EF. Remember, tangent means it touches the circle at one place, and it touches it right here at point G, which is 3, 6. And tangent means that my line of tangency has to be perpendicular to my radius. Therefore, if the slope of my line of tangency is 5/3, the slope of GP has to be perpendicular. Perpendicular means negative reciprocal. So the slope of GP has to be negative 3/5. Moving right along, number 10. This is another one we have to draw out. So I've got circle K, and I'm going to draw a triangle. Sort of. This is triangle GHI. I know that GH is 20, HI is 14, and IG is 12 units. Okay, I need to know how long this segment is right here with points tangent here. So one of my theorems says that if I have 2 lines that are tangent with a common endpoint, they are congruent. So these 2 tangents are congruent, these 2 down here are congruent, and these 2 over here are congruent. Okay? Now I don't know any pieces of this, I just know the whole long segment. So I'm going to give them little variables. I'm going to say that these are X. I'm going to call these little segments Y, and these segments Z. Okay, what I'm going to do is I'm going to write 3 little mini equations. X plus Y equals 20. X plus Y is 20. I know that Y plus Z is 14. And then I also know over here Z plus X is 12. I am going to solve this one in terms of Y. So what does Y equal? Y equals 14 minus Z. Because then I can substitute this right here. I'm going to solve this one for X. x equals 12 minus z. So I'm going to plug that in. So x, 12 minus z, plus y, 14 minus z, equals 20. So let's combine our like terms. And we have negative 2z plus 26 equals 20. It's minus 26 from both sides. And I get negative 2z equals negative 6. So z equals 3, which is great. That means this length right here is 3. And this length over here is 3. Now I could just substitute it in. 3 plus something is 12. 3 plus what? 9. And that's what I want to know. I want to know the points of tangency on GH. So this segment right here and this segment right here. I wanted to know X. So my answer is 9 units. And I'm going to write it right over here. Okay, number 11. I'm just going to sort of draw a line around that. Number 11 uses theorem 10.15, which we talked about today in class about special segments, and I have two secants. So I know that these two secants, the product of their parts are equal. So 3 times x plus 5 is equal to 4 times x plus 1. That's what my theorem says. Let's distribute. 3x plus 15 equals 4x plus 4. And let's combine like terms. Let's subtract 3x. And let's minus 4. So that gives me 11 equals x, which is what I wanted to know. Number 12, this is theorem 10.16 in your book. And this theorem says that there is also a relationship, but I need to know the whole length. The length of that whole segment is x plus 1, and the length of this whole segment is 14. And my theorem states that the product of the total length plus the piece that's outside is equal to the total length times the piece that's outside. Let's simplify that. 14 times 4 is 56. X squared plus x. Now we talked about this a lot in class, that I do not have an x squared on the left side. So what do? That is your clue to move everything to the right side and set it equal to 0. Because then I want to know if I can factor. And remember factoring, I'm going to come off to the side and I'm going to put factors of negative 56. So we've got 2 times 28. Can I rearrange that any way to add to get 1? Nope. How about 4 times 14? Can I rearrange that any way to add together to get 1? Nope. How about 7 times 8? Hey, yes I could. I need positive 1. So if I have negative 7 and a positive 8, that works. So in my parentheses, x minus 7, x plus 8. My answer, though, says to solve for x. So I'm going to set each one of these equal to 0. And I'm going to get 2 answers. I'm going to get x equals 7 and x equals negative 8. Now remember, we talked about you have to use common sense. Can x, or can the length be negative? No, you can't be negative 5 feet tall. So x can only equal 7. That's the only one that makes sense. All right, this last couple ones here, 13 through 16, your shape is going to get pretty complicated. So what I suggest first is, let's look at what I'm going to find. PQR. PQR, this angle right here. Okay, let's find each of these angles first. I'm going to come over here to the side. Angle R, we're going to use one of our theorems that talks about the relationship between the arcs. Okay, so if this is 140, then how much is this angle right here? It's 220. So angle R is 1/2 of the difference of 220 minus 140. I got 220 by subtracting 140 from 360. Angle R is 40 degrees. Okay, let's find angle P. Okay, angle P is 1/2 of, now here's 100, so 360 minus 100 is 260. So angle P is 80 degrees. Okay, since I know both of those angles, can I find angle Q? Angle PQR, and this was using mainly theorem 10.14. That's what I used a lot on up here, theorem 10.14. PQR is going to equal 180 minus the sum of these two angles, which is 60 degrees. Okay, so angle Q is 60. All right, here's where we start to get a little complicated. I want to find X, Y, Z. X, Y, Z. This inscribed angle. This is going to be using theorem 10.16. Oops, it's not 16. 10.6. And remember, inscribed angle equals half the measure of the arc. So angle XYZ equals 1/2 the measure of my arc, which is given to me, 140. So half of it is going to be 70 degrees. Okay. Now here's where we're going to get a little interesting. PYX. PYX. This angle is on the circle, but it is not inscribed. And it's not outside. So we're going to look up theorem 10.11 on this. Theorem 10.11 says we're going to take our angle up here, and we're going to subtract 180 from it and divide it by 2. The reason why is because PX is tangent and PY is tangent. Because those two are congruent, PYX and PXY are both equal. They are congruent. So PYX equals 180 minus 80, this top angle, divided by 2, which is 50 degrees. There, now you can see what I did. Okay, number 16, last one. Find measure angle XUZ. XUZ. UZ, this angle right inside, we're going to use theorem 1012 that talks about the relationship between two secants and their angles and the arcs opposite them. So we're going to be talking about arc XZ and arc YW. Okay, so I'm going to put this back up here so you can see it. And again, this is theorem 10.12. Angle XUZ equals 1/2 of the sum of the arcs opposite. So let's look up here. The arc opposite, it is 140. And then what is the arc opposite of that? Well, here's the diameter. So if this is 180, here's 140. So WZ arc has to equal 40 degrees. Then that means this whole arc is 180. I know that there's 100 here, which means that WY has to be 80, which is what I need, the arc opposite the angle. Okay, so 1/2 of 140 plus 80 equals 110 degrees. And that was theorem 10.12. Okay, number 17, write the equation of a circle. Our equation says x minus h squared plus y minus k squared equals r squared. H and k, remember, are your center. So here's my center, here's h, here's k. So let's just substitute in x plus 7 squared plus y minus 8 squared. And my radius squared, 9 squared, is 81. There's my answer. Ooh, now I get to write one where I don't know the radius. I know my center, my h and my k, but how can I find my radius? Remember, if the point is on the circle, then from the center to the point is a radius. So I can use the distance formula. 8 minus 4 squared plus 1 plus 9 squared. Simplify that, and that gives you the square root of 116. So let's plug it in. X minus 4 squared plus y plus 9 squared. Now my radius squared, if I square a square root, that cancels out the square root. So there's my answer, my equation. Okay, last two problems. Yay! Number 19. I'm going to find the radius. I know that from this equation that my center is the point -3, 2. And I have a point on the circle. So just like my last problem, I am going to use the distance formula again. So -3 plus 0 and 2 minus 3. Or I'm sorry, 2 minus 8. Can't read my own writing. Squared. This gives you the square root of 45. So my radius is the square root of 45, but let's simplify that because 45 can be simpler. Let's split this up. This is 9 times 5, so this simplifies to 3 roots of 5. Okay, number 20, we're going to graph. Remember, when graphing a circle, we need to know the center and we need to know the radius in order to graph it. So looking at this, my center is 3, -1. So I need to sort of make up axes, but since I don't know how big my circle is, let's find the radius. The radius is the square root of this, so 5. So pretty big circle. So let's make our graph sort of more towards the left. So here's one axis, and I'm going to make this sort of in the middle. Trying to darken it so you can see it. So 3, -1 is my center. I'm going to go up 5. 1, 2, 3, 4. I'm going to go down 5. I'm going to go left 5, and I'm going to go right 5. And then I'm going to sort of sketch a circle. As long as it does not look like a square, you're good. There's my circle. Now the bonus, you get to try to figure that out. I will tell you, you need to graph it. I'm going to tell you this circle right here, circle number 1. I will get you started. Find the center. Find the radius. Do the same thing for this circle. Number 2. Find the center. Find the radius. You need to graph it. There are 2 points I am looking for. If you have the correct 2 points, show me on Wednesday and I will give you 5 points extra credit.